Hello and welcome to lesson 2 of week 10. We're going to take a look at the Pythagorean theorem today. So I can use the Pythagorean theorem to solve problems involving right triangles and determine that a triangle is a right triangle using the converse of the Pythagorean theorem. So the Pythagorean theorem you've probably seen before. It is for all triangles with a right angle. If the squares are made on each of the three sides, the area of the biggest square is exactly the same as the area of the other two squares added together. Now, we can write it as an equation. A squared plus B squared equals C squared. I can also show you visually what that looks like. So we got a little right triangle here with side lengths A, B, and C. Side length A makes a square that's A by A, or A squared. Side length B makes a square that is B by B, or B squared, and same thing with C. So A times A is A squared, B times B is B squared, C times C is C squared. The green square plus the purple square will add up to be exactly the same as the red square. This theorem only applies to which type of triangles? Acute, obtuse, or right? It is right triangles. You should know that. I'm pounding that in. So here we go. Right triangles. You see the right angle there. They have something called a hypotenuse. The hypotenuse is the longest side. It's opposite the right angle. We call it side C. The legs are the two sides that make the right angle. So A and B, where they come together, that's where the right angle is. So we're going to use that theorem to find the length of the hypotenuse, and we're going to leave it in simplest radical form. So we're going to use A squared plus B squared equals C squared. In this case, we're looking for C. 6 is A and 9 is B, and those are interchangeable. I could say 6 is B and 9 is A. It does not matter. I'm going to plug those in. So 6 squared plus 9 squared equals C squared. Well, 6 squared is 36, 9 squared is 81, and C squared. 36 plus 81 is 117. Now to get C and not C squared, I have to take the square root of both sides. Why? Because the square root and the squared cancel each other, and that gives me just C. Well, the square root of 117, it can be broken down into 9 times 13. The square root of 9 is 3. Square root of 13 is a prime number, so square root of 13 stays inside the radical. The length of the diagonal, or the hypotenuse here, is 3 radical 13. How about this one? We're looking for something different here. C is actually known this time. It's 4 radical 5. We're looking for B, which means 2 radical 7 is my A. So I'm going to put 2 radical 7 in for A. Make sure you put parentheses around that. If you don't, it'll give you something different. Plus B squared equals 4 radical 5 squared. Well, 2 radical 7 squared, you square the 2 and the radical 7. So 2 squared is 4. Square root of 7 squared is 7. So 4 times 7. Plus B squared. 4 radical 5 squared is 4 times 4, which is 16. And square root of 5 times square root of 5 is 5. 4 times 7 is 28. Plus B squared equals 80. Subtract 28 from both sides to get B squared by itself. Then I take the square root of both sides, and then I break down 52. So I get 4 times 13. Square root of 4 is 2, and the 13 stays under the radical, so it's 2 radical 13. Okay. Find the distance between the 2 points. So on a coordinate plane, you can actually use the Pythagorean theorem. By dropping something straight down and going straight over, you found the 2 legs. You can actually count the length of the legs. In this case, the bottom leg is 5, so 1, 2, 3, 4, 5. The vertical leg is 1, 2, 3, 4, 5, 6, 7. So I can plug those things in. 5 squared plus 7 squared equals C squared. 25 plus 49 equals C squared. 74 equals C squared. If I take the square root of both sides, 74 actually does not break down. There's no perfect squares that go into 74. Therefore, my answer is the square root of 74. If you wanted a decimal approximation of that, you would type that in, and you would get 8.6 or 8.7, something like that. What about this example? So you're standing up here at the top of this diving platform that's 16 feet off the water. Looking down, you see the ball on the water 12 feet from the bottom of the diving platform. Find your distance from the ball. So if I put a triangle in here, I'm 16 feet off the water. The ball is 12 feet from the bottom of the platform. You see the right triangle here? We can do A squared plus B squared equals C squared. 16 squared plus 12 squared equals c squared. You do that, and you should get 400 equals c squared. When you take the square root, you get 20. It's a perfect number. So you are 20 feet from the ball. One more thing with Pythagorean theorem, there's a converse which says that if a triangle has side lengths of a, b, and c, and a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, so basically, you can determine if a triangle is a right triangle by using the Pythagorean theorem. So if the side lengths satisfy or make that equation true, then the triangle is a right triangle. If they do not, then it is not a right triangle. So here's a couple examples. 6, 24, and 25. If I put that in for a squared plus b squared equals c squared, I get 6 squared plus 24 squared equals 25 squared. The biggest side has to be the one that's by itself. That you need to make sure you see that. So I just see, are the two sides equal? Well, 36 plus 576 is 612, which is not the same as 25 squared or 625. Since they're not the same, this is not a right triangle. Second one, 10 squared plus 24 squared equals 26 squared. That's 100 plus 576. Does that equal 676? It does, which means this is a right triangle. Right? And so that's the Pythagorean theorem and its converse. And we're done with this lesson.